A quick video, kind of a supplement to a video that the Burb Billy is going to produce. I hope I'm not stealing his thunder too much here. I just want to give some technical details on it because I gave a reply to Burb Billy. This is kind of a continuation of that reply. I didn't do it under Hill's workbench, unfortunately. So this is just a quick summary of how things go in North America, North American power system. I wasn't able to verify whether they actually use this in South America or even in Mexico. I believe they do. I'm not sure. If anybody knows how Mexico power goes, let me know. I couldn't find it real quickly. I know Canada uses it the same. And by the way, if there's any corrections to this, note them in the comments. I'm not an electrician or electrical engineer, so take it with a grain of salt, I suppose, although I'm 99.9% sure all the information in this video is accurate. I am not a professional in that line. I talked about a channel called the Burb Billy before. He recently posted a video on what happens when you lose one of your wires from the pole, or it could be in your meter box. You know, a terminal can burn up, or with corrosion, or otherwise get disconnected. There's also connections at your fuse box. There's also connections at the pole. Any one of those can go bad, making any one of these three wires go out. And he's covered the first condition, which is if one of these two come out. And he's going to do a video, I wrote down here, much worse is when neutral from the pole fails. Very dangerous. Could have nearly 240 volts on half your outlets in an extreme case. Typically the lights are going bright dim. The cable TV or phone line might be smoking as the neutral current tries to find a path. Usually the water line ground takes the brunt of it, which is why the ground and the meter bypass ground are so important. You've got a ground wire going across your meter to prevent current from going through the meter, which is a casted bronze housing or something like that usually. Can't take the current too well. So they do a bypass. Now, if you lose this neutral line, the cable TV wire to the pole, sometimes the phone wire to the pole, or your plumbing, which is usually a copper, or if it's an old house, a lead line coming from the ground. Well, if the neutral breaks, this line is going to take the brunt of the current. That's why they want that jumper across to keep the meter from overheating and burning up and dropping too much voltage as well. But this is not where you want your neutral current to be flowing. You want it to be flowing through this wire. Ideally, if you put an amp meter, one of the kind, a clamp amp meter, which will encircle something as big as a pipe, you can, typical clamp meter will do that, go right around the water pipe. You should have very low current there. I have 0 amps, and if you used a volt probe to ground, you should get 0 volts. You know, that's ideal. You're always going to have some amperage and some current, some voltage, but you want that as low as you can. If you did put a clamp amp meter here, and you watched it for a while, you'd want to watch it while different appliances are turning on and off in the house. If you started seeing major amperages, you know, 10, 20 amps going down that line, then you've definitely got a problem. And it's being camouflaged by your plumbing being such a good ground. Usually the plumbing isn't that great a ground, and you start to see the lights going bright dim in the house severely. Some outlets will have more voltage than 120, some outlets will have less than 120 volts on them. It wouldn't get to 240, only in an extreme theoretical case. So, coming off the main lines, it isn't the super high voltage, but it's a voltage they use around the neighborhood to connect several transformers, you know, small transformers up. And it'll be in the kilovolts. It'll be as low as 5 kilovolts or as high as in the 30s. It all depends on the electrical company that's doing the work. They're not all the same. I know I used to live on the other side of the state, and almost everything was 12.2 kilovolts. But I know around here it's different. I don't think they even use 12 kV that much. Anyways, you've got a hot line. You've got what's basically a center tap transformer. You got the hot side with some kilovolts in. The output side is a 240 volt transformer with a center tap. So you've got 120 volts if you go from the center tap to one of the hots, the L1 or the L2, you've got 120 volts. If you go from L1 directly to L2, you've got 240 volts, because these are out of phase. 180 degrees out of phase. So it'll pass through the meter. I don't think the old meters needed a neutral connection, but the new ones probably do, the electronic ones. At any rate, it goes into rails in the box. In reality, the neutral is on a bus bar in the box, and all your neutrals will all these white wires will be going to here for neutral. And your grounds. Your ground to the earth should go to a ground rod. Your ground from the pole, which is this wire here, this neutral. And also, if you've got metallic plumbing in your house, there should be a ground wire to your plumbing. And that's how it gets back to your meter, your water meter, in a case of a failure of this neutral. So you've got mostly 120 volt breakers loaded in the box here, and half of them are going to be on L1 and half are going to be on L2. And then you've got a 240 volt breaker, which is connecting to both L1 and L2 and putting it out. In reality, the L1 and L2 are kind of twisted, or fingers. There's like fingers coming off of them, so that as you go down one side, and this is different panels, so I'm just giving a generality here. Let's say one side of the panel, usually you have two rows of breakers, and then on one row would hit this side, the other one would hit this side, and the fingers, kind of like one is L1 and the next finger is L2, they interlace. And then a 240 breaker hogs both spots and connects to both an L1 and an L2. So every other breaker is L1, L2, or here L1 and L2, all the way down on both sides. That's typical. There's going to be variances. Your typical 120 volt outlet, long side is neutral. The pin, if there is one, is an outlet. There's always going to be a pin, or almost always, unless it's an ancient outlet. And then the shorter slot is the hot 120 volt. So basically 0 volts, 120 volts. You know, ideally these two are going to always be the same 0 volts. Of course, they're never going to be ideal. The other thing I mentioned is the ground right at the pole, where this neutral is also connected. That's relevant because if this neutral wire is broken, your neutral current is going to go into the earth, and into your water line, and back into your house. That's no way to run a railroad. Especially if you've got an old lead line and this condition develops, potentially you could be disturbing that oxide layer in your pipe, you know, if you're heating that pipe up. And lead isn't a great conductor, so it will heat up a little bit. That is not a situation you want happening. So, especially if you've got a lead line, you definitely want 0 amps. And, you know, any house that's from the 50s or earlier probably has a lead line coming into it. And believe it or not. The 240 volt outlet are different. They're bigger because we use 240 volts in North America only for our big appliances. We don't have the insane 240 volts at the wall. That's kind of nuts the way, in my opinion. But the shape of these will actually vary quite a bit. There's at least 3, probably more configurations. One kind of looks like this with all slotted prongs, but some of them have a prong going different direction, or a pin. Usually they're slots, but there are different shapes and orientations of one slot or all slots or whatever. And the differences are for a variety of different amperage capabilities. So a 30 amp outlet you know, will be different than a 50 amp outlet, potentially, if everything's, you know, done right. And typically you buy a big appliance like an air conditioner or a dryer, and then you match the outlet to whatever the cord was that came with the unit, which should match the current needed, you know, and not too much more. So anyway, that's basically what I wanted to go over with this, just to give a general understanding of how everything's hooked up. And this illustration shows my ground pole. Vandals in my town have stolen the last few feet, almost every pole, as high as a guy can reach to the ground. They snipped out the frickin' ground wire just to get that few cents of copper. You know, meanwhile, probably having someone drive them around to do it, you know, and then running out and doing it and burning gasoline. I can't imagine you'd make enough money to really make that worth your while, but people do anything for a buck. Almost every pole in this city is missing its ground. So, things I'd like to say in safety-wise, if your lights are going bright dim, then this is definitely something you got to check into. There should be no current going into your water line. Whenever you got a bright dim thing going on, especially if it's something actually brightening, not just dimming, but actually brightening up. And of course, if you have dimmers in your house, it'll kind of magnify the situation. So I'm not really talking about a dimmer light, you know. But if your standard light bulbs are going bright dim, there's something wrong. If you do detect this condition where you've got some outlets high, some outlets low, then you need to get help immediately, you know, ASAP. Depending on your electrical company, the service drop may or may not be the company's responsibility. It seems to vary in areas. But you just got to start making phone calls and find out what you got to do if you got that situation going on. You don't want to use your wash machine, you know, reaching into the water that's grounded when your neutral isn't no longer grounded, that's on the side of it. You could really potentially be in a lot of trouble. So I'm sure Burb Billy will make his video on this and probably give you a more practical aspect. I just want to give you some of the technical aspects of it.